Want to design a warehouse that works smarter, not harder? Tired of wasted space, slow order fulfillment, and rising costs? These 8 warehouse design principles are the secret sauce behind Amazon, Walmart, and top-tier logistics operations. We're diving into these, not just what they are, but why they matter, how to implement them, and how they drive real results, with practical, numerical examples you can apply instantly. Welcome to 10 Minutes for Supply Chain, where we simplify complex supply chain concepts. Stay tuned, because one principle could save you thousands in labor and space costs. Let's start. 1. Space utilization. Space utilization refers to the efficient use of available warehouse space, both horizontally and vertically. It is important in maximizing usable space, lowers the cost per unit of storage, and delays the need for facility expansion. It helps warehouse operation as it improves storage density, reduces travel time for pickers and forklift operators, enhances safety with organized layouts, and reduces facility rental or construction costs. How to implement. Install vertical racking systems. Use narrow aisle forklifts. Introduce mezzanine floors. Use stackable containers or bins. Example. A warehouse has 100,000 square feet of floor space and 30-foot ceiling height. Initially, only 10 feet is used vertically, giving a storage volume of 1 million cubic feet, 100,000 x 10. By installing racking systems up to 25 feet, the usable volume increases to 2.5 million cubic feet, a 150% improvement in space utilization. 2. Flow optimization. It refers to designing the warehouse layout to ensure a logical flow of goods from receiving to storage, picking, packing, and shipping. It is important to reduce material handling time and prevent congestion. It helps warehouse operation as it minimizes unnecessary travel, streamlines operations, reduces handling errors, and enables quicker turnaround for order processing. How to implement. Create U-shaped or straight-through layouts. Use visual flow maps. Position fast-moving inventory near dispatch zones. Align storage and processing zones to support seamless product movement. Example. A warehouse has 500 orders daily. Without flow optimization, average picking and packing takes 30 minutes per order. After redesigning the layout to place fast-moving items near packing stations, time drops to 20 minutes, saving over 80 man-hours per day. 10 minutes x 500 orders/60. 3. Accessibility. It refers to ensuring that every item stored is easily accessible without moving other items. It is important to improve pick accuracy and speed and reduce damage. It helps warehouse operation as it facilitates efficient stock rotation by FIFO/LIFO strategy, reduces picking errors, accelerates fulfillment, and minimizes product damage. How to implement. Use single deep racking for fast-moving items. Implement barcode bin locations. Designate clear picking paths. Avoid overstacking or deep pallet rows. Example. A warehouse stores 10,000 SKUs. Initially, SKUs were stacked randomly, causing delays and errors. By implementing bin locations with barcoding, accessibility improved, reducing picking errors from 5% to 1% and improving picking speed by 40%. 4. Scalability and Flexibility. It refers to designing the warehouse to accommodate future growth or changes in operations. It is important to enable quick adaptation to market demand and reduce long-term costs. It helps warehouse operation as it allows seamless expansion, prevents bottlenecks during growth, supports seasonal demand spikes, and extends warehouse lifespan. How to implement. Use modular racking systems. Design open floor layouts. Select equipment and software that can scale. Allow spare capacity in utilities and network cabling. Example. A warehouse initially designed to handle 5,000 pallets installs mobile racking. As demand grows, the racking is expanded to 8,000 pallets with minimal downtime. The company avoids renting external space, saving $50,000 annually. 5. Safety and Ergonomics. It refers to designing the layout to ensure the safety of workers and equipment and optimizing human movement. It is important to reduce workplace injuries and insurance costs. It helps warehouse operation as it promotes workforce well-being, reduces injury-related downtime, minimizes compensation claims, and boosts morale and productivity. How to implement. Create wider aisles for forklifts. Use ergonomic picking tools and lift assists. Implement signage, floor markings, and safety barriers. Conduct regular training and audits. Example. Improperly designed aisles cause 10 accidents/year. Redesigning aisles to include wider passages, anti-slip floors, and ergonomic picking zones reduces accidents to 2/year, saving $70,000 in medical and productivity costs. 6. Technology integration. It refers to planning warehouse infrastructure to support automation and IT systems like warehouse management systems, WMS, RFID, or AS/RS. It is important to improve accuracy, real-time tracking, and operational control. It helps warehouse operation as it reduces errors in manual labor, improves real-time visibility of stock, supports demand forecasting, and enhances decision-making. How to implement. Integrate WMS with ERP systems. Install wireless networks throughout the warehouse. Use barcode scanners, RFID tags, and automated picking systems. Ensure technology compatibility with existing workflows. Example: a warehouse using paper-based picking experiences 3% error rates. After integrating a WMS with handheld scanners, errors drop to 0.5% and labor productivity increases by 25%, handling 125 orders/day per worker instead of 100. 7. Energy efficiency. It refers to incorporating systems and materials that reduce energy consumption. It is important to reduce operational costs and support sustainability goals. It helps warehouse operation as it lowers utility expenses, reduces environmental footprint, supports green certifications, and improves indoor comfort for workers. How to implement. Use skylights and solar panels. Switch to LED lighting with motion sensors. Invest in high-efficiency HVAC systems. Use insulated dock doors and reflective roofing. Example: switching from traditional lighting to motion-activated LED lighting reduces electricity usage by 40%. Monthly utility bills drop from $10,000 to $6,000, saving $48,000 annually. 8. Zoning and slotting. It refers to dividing the warehouse into functional zones and placing items based on demand frequency and size. It is important to reduce travel time and enhance pick efficiency. It helps warehouse operation as it improves order picking rates, reduces worker fatigue, minimizes errors, and supports seasonal adjustments in layout. How to implement. Conduct ABC analysis of inventory. Assign fast-moving items to golden zones. Design separate areas for receiving, quarantine, storage, and dispatch. Update slotting rules based on demand trends. Example: a company reassigns top 20% SKUs, which account for 80% of picks, near the dispatch area. Picker travel distance per day reduces from 12 kilometers to 8 kilometers, saving 4 hours of walking time per shift. Conclusion. Warehouse design is more than just physical structure. It's a strategy that directly impacts cost, speed, and accuracy. Each principle, from space utilization to zoning, works together to build a resilient and efficient supply chain. Organizations that prioritize strategic warehouse design gain a significant competitive edge in service level, cost efficiency, and adaptability. If you enjoyed this breakdown, give it a like, share, and subscribe for more warehouse wisdom. Hit the bell so you never miss a logistics deep dive. Become a channel member for exclusive content, live Q&As, and global updates from the front lines of supply chain. Thanks for watching. Until next time, stay informed and supply smart.